On March 31, 2026, security researcher Kaofin Xu, who goes by Xiao on social media, noticed something that Anthropic almost certain. Li did not want the world to see the entire source code for Claude Code. Their flagship command line interface tool was sitting in plain sight on the npm registry. Here is what happened when the @Anthropic AI/Claude Code package was published to npm. It included a sourceMap file. Source maps are meant to help developers debug their code by mapping minified production code back to the original source. But here is the catch: source maps often contain the actual original source code embedded right inside them as strings in a JSON file. And that is exactly what happened here. The sourceMap file referenced unobfuscated TypeScript that was stored on Anthropic's own R2 cloud storage bucket. Anyone could download it as a zip archive directly from Anthropic's infrastructure. We are talking about roughly 1,900 files and over 512,000 lines of code. Everything was suddenly available for the world to examine. Kaofin Xu announced the discovery publicly on X, and the response was immediate. The leaked codebase was quickly archived to GitHub repositories, where it gained significant attention from the developer community within hours. Engineers were picking through the code, analyzing the architecture, and documenting what they found. It was one of those moments where a simple configuration oversight exposed the crown jewels of a major AI company's software infrastructure. So how does a source map actually work, and why does it end up leaking entire codebases? The answer lies in what these files are designed to do. Source maps were created to solve a genuine problem in modern web development. When you write TypeScript or modern JavaScript, that code gets transformed before it reaches production. It gets minified, bundled, and compressed into something that runs fast, but becomes nearly impossible to read. A source map bridges that gap. It lets developers debug production code by mapping the obfuscated output back to the original source files. The problem is in the implementation. A source map file is just JSON, but inside that JSON are three critical fields. The sources array lists every original file that went into the build, showing paths like ./src/main.ts. Then there is the mappings field, which contains base64 encoded data that links each position in the minified output to a position in the original source. But the real treasure or liability, depending on your perspective, sits in the source content array. This field contains the actual raw source code from every file embedded as strings, every comment, every internal constant, every piece of logic your team wrote is sitting there in plain text. This happens over and over in the industry because the mistake is so easy to make. Developers either forget to add *.map to their npm-ignore file, or they do not configure their bundler to skip source map generation when building for production. In the case of Claude Code, the tool uses bun as its JavaScript runtime, and bundler bun generates source maps by default, unless you explicitly disable them. One missing configuration line, one overlooked file in the ignore list, and suddenly your entire codebase ships to the public registry. It is a simple oversight with massive consequences, and it keeps happening because build tooling prioritizes developer convenience over security by default. So what exactly was sitting inside that source map file? The numbers are honestly staggering: nearly 1,900 TypeScript files, adding up to more than 512,000 lines of code. This is not some weekend project or a thin wrapper around an API. This is a full-scale production system with serious engineering behind it. The technology choices revealed a lot about how Anthropic thinks about building developer tools. They went with bun as their JavaScript runtime, instead of Node, which makes sense when you see how much they care about startup speed. Fun. Dead code elimination helps them strip out feature flags and keep the tool feeling snappy. Then there's the user interface approach. They built their terminal UI using React with a library called Ink, that means component-based architecture, state management. All the patterns you would expect in a web application, but running in a command line environment. Schema validation shows up everywhere through Zod version for every tool input, every API response. Every configuration file gets validated. It is a defensive programming style that pays off when you are dealing with the unpredictable outputs of a language model. They also made smart choices about dependencies. Heavy modules like OpenTelemetry and gRPC are lazy loaded, meaning they only get pulled in when actually needed, keeping the initial startup fast. The architecture itself follows a modular plugin style system. Each capability, whether it is reading files, executing bash commands, or integrating with language servers, operates as a discrete tool with its own permission gates. The main entry point, a file called main tsx, weighs in at 785 kilobytes. That's a hefty bundle, but it reflects just how much functionality they packed into this single tool. Let us start with the biggest piece of the puzzle. The query engine is massive at around 46,000 lines of TypeScript. This single module is the brain of the entire operation. Everything that involves talking to Claude's models flows through here. API calls, streaming responses, caching strategies to save on tokens and costs, orchestration of complex multi-step operations. It is all in there. What's fascinating is how much complexity goes into something that seems simple from the outside. When you type a prompt and hit enter, there's this entire engine humming away, managing retries, handling rate limits, deciding what gets cached and what does not. Then there's the tool system. The base definition alone spans about 29,000 lines. Each tool, whether it is reading files, editing code, running bash commands, or spawning subagents, follows a consistent pattern. They are all permission gated, meaning the system checks whether you have authorized that specific action before it executes. There are roughly 40 distinct tools in total. Bash tool handles command execution, fileread tool, and fileread tool manage your codebase. Agent tool is particularly interesting because it lets the system spawn entirely new agent instances. That brings us to the swarms concept. When Claude Code encounters a task that can be broken into parallel pieces, it spawns what they call sub-agents. Each one runs in its own context with specific tool permissions, working independently before reporting back. It is like having multiple Claude instances collaborating on different parts of the same problem. The IDE bridge system connects all of this to your editor. VS Code, JetBrains, they all communicate through JWT authenticated channels. And then there's what they call the dream system. It runs in the background, consolidating memories about your project, your preferences, your patterns. Even when you are not actively using it, the system is learning. The leaked source code revealed something fascinating that Anthropic had been keeping under wraps. Buried in the feature flags were codenames that hint at where the company planned to take this tool. Next there was proactive, suggesting some kind of anticipatory assistance mode, voice mode, which speaks for itself. Bridge mode, likely related to deeper IDE integrations. And then there is Kairos, an intriguing name that could represent almost anything from a new model integration to an entirely different product direction. These were not mere ideas scribbled in a planning document. They were implemented. Feature flags, waiting to be flipped on the code, also exposed a persistent memory system that most users probably did not know existed. This system creates a file-based memory directory, where Claude stores context about you, your project, and your preferences across sessions. It remembers what you worked on yesterday, last week, last month, your coding style, your project structure, your preferences. It is essentially a long-term brain for an AI that most people assumed forgot everything the moment you closed the terminal, and then there were the slash commands, about 85 of them, spanning everything from Git workflows to code review to memory management. This was not just a chat interface, it was a full command line environment with its own rich vocabulary of actions. But here is the part that is genuinely hard to believe: Claude Code had an entire subsystem called undercover mode. Its sole purpose was to prevent Anthropic's internal information from leaking out. It was designed to catch internal codenames in Git commits to stop the AI from accidentally revealing things it should not. They built a sophisticated system to prevent exactly this kind of leak, and then they shipped the entire source code in a sourceMap file. The irony is almost painful. The very tool designed to keep secrets became the vehicle for exposing them all. Once the source code was out there, things moved fast. Within hours, the leaked codebase had been archived to public GitHub repositories, where it quickly garnered over 1,100 stars and nearly 2,000 forks. The cat was well and truly out of the bag, and the developer community did what it always does when something interesting lands in public view. They preserved it, studied it, and started building on top of it. But here's where things get particularly interesting from a legal and ethical standpoint. A developer going by Kuberwastaken launched a clean room reimplementation project, rewriting Claude code in Rust. The approach was deliberately careful. First, an AI agent analyzed the original source and produced detailed behavioral specifications documenting what the software does without copying how it does it. Then, a completely separate AI agent implemented those specifications in idiomatic Rust, never once referencing the original TypeScript code. This two-phase process mirrors established legal precedent, specifically the Phoenix Technologies versus IBM case from 1984, which validated clean room engineering for BIOS reverse engineering, and the earlier Baker versus Selden ruling from 1879, which established that copyright protects expression, not ideas or behavior, for organizations integrating AI coding tools into their workflows. This incident raises uncomfortable questions. If a company like Anthropic, with significant resources and engineering talent, can accidentally ship their entire source code through a bundled sourceMap, what about everyone else? The reality is that sourceMap leaks are not some exotic attack vector. They keep happening because the mistake is almost always the same: someone forgets to configure their bundler properly, or neglects to exclude map files from the production package with build tools, generating source maps by default. The burden is on developers to explicitly turn them off for production builds, and that is a step that gets missed more often than anyone would like to admit.